Hi everyone, today we are going to integrate all that we have learned on mole, mass, volume and concentration and apply it in calculations for chemical reactions. Just a very quick recap. To get mole, we divide mass by molar mass. To get mole, we divide volume by molar volume. And to get mole, we multiply concentration with volume. So this is usually for gas or solid. This is only for gas and this is for solutions only. Now let's look at comparison of mole. Whenever we look at any chemical equation, the first step is to look at the coefficient in front of the substances. If there's no number written, that means it is 1. So for this example, it is 1 mole of A reacting with 1 mole of B to give 1 mole of AB. So let's say 0.5 mole of A has to react with 0.5 mole of B to produce 0.5 mole of AB. Likewise, let's say 2 mole of AB is produced. 2 mole of AB is produced from 2 mole of A reacting with 2 mole of B. So that's how we compare mole using chemical equation. So just another example, 2P plus Q giving us P to Q. So in this example, the ratio is 2 to 1, producing 1 mole of P to Q. Alright, so let's say 0.1 mole of P has to react with half of this value for Q, which is 0.05, and also 0.05 mole of P to Q is produced. Because the ratio is 2 to 1, so we have to divide by 2. So likewise, let's say 3 mole of P2Q is produced. We can trace backwards. So for P, it should be 6 mole because it's 2 times, 2 to 1. For Q, it's the same ratio, so it's 3 mole. So that's how we use the chemical equation to help us to compare the number of mole. So be reminded, whenever we do calculations for chemical reaction, the first thing we want to get is the number of mole for all the reactants. So that's why these 3 formulas, they are very important. You need to know how to get the mole if you are given the mass, volume, and concentration. So let's look at some examples. Alright, for the first one, this is a reaction of magnesium with hydrochloric acid giving us a salt and gas. It can be represented in this equation. The equation is balanced. And the question is asking for volume of hydrogen gas produced if excess magnesium reacts with this amount of HCl. So now, the information given, first, it is excess magnesium. We have covered this before. If something is in excess, we will not use that for calculation. We will use the limitant reactant for calculation. And the information given here, we have the volume, we have the concentration, so we can find the number of mole of HCl. So let's do that. First, we need to convert the volume, cm cubed to dm cubed. Then we just multiply the concentration with volume, we'll get the number of mole. So the number of mole for HCl is 0.1 mole. And now we want to compare the mole for HCl and hydrogen. So the ratio is 2 to 1. Alright, HCl to hydrogen gas is 2 to 1. So if we have 0.1 mole here, it should be 0.05 mole for hydrogen gas. And now we have 0.05 mole of hydrogen gas. We can just multiply by molar volume to get the volume, which is 1.2 dm cubed. And that's the answer for this question. 1.2 dm cubed. We do not need to change to cm cubed if the question did not say so. Now for example 2, it's a similar chemical reaction, just that now we have zinc in zinc. So zinc reacting with hydrochloric acid giving us zinc chloride and hydrogen gas. And in this question, it's the other way around. Hydrogen gas, the volume of hydrogen gas is given, and we are to trace backwards to find the concentration as well as the mass of zinc left. So let's look at the first part to find concentration of HCl. So we just list down whatever information we have. We have the volume of hydrogen gas. So be reminded, the first step is always to find the number of mole for the substances. In this case, we are starting from the product. So to find the number of mole of hydrogen, we divide by molar volume. So we get 0.01 mole or 15 mole. And the next step is to compare the ratio HCl with hydrogen gas. So the ratio is 2 to 1. And now we can find the number of mole of HCl, which is 0.03. And the question tells us there's 100 cm³ of hydrochloric acid. We change it to dm³. So now we can find the concentration by dividing mole with volume. So the concentration of HCl is 0.3 mole per dm³. So that's for part 1. For part 2, we are asked about the mass of zinc left. That means zinc is actually in excess because there's still some zinc left after the reaction. So 1.5 mole is in excess. We want to find the amount of zinc that has reacted. So the same method, we find the number of mole of hydrogen, which we have done that just now. And now we just need to compare zinc with hydrogen gas. And from the chemical equation, we know the ratio is 1 to 1. And we can actually find the number of mole of zinc now, which is the same, 0.015 mole. And from mole, now we want to find mass. So we multiply by the molar mass of zinc, which is 65. So we get 0.975 gram that has reacted. So what is left, we just minus from 1.5, then that's the answer, 0.525 gram. So that's all for the second part of chemical reaction calculation that has to do with concentration, solutions, and solids and gas. But the general idea, the first is always to find the mole, and then we compare the mole. So that's all for this lesson.